Currently, entire internet traffic is being monitored, and sometimes when you need to visit the resource from another city because it's unavailable to you, or let's say if you are a developer and you want to simulate different location login process, you probably have to use a VPN service or one of the variations of VPN that is available there. And VPN plays a huge role currently in the internet because most of the parts of the world don't have access to a proper internet resources, or they are blocked by their governments, so they have to have a VPN in order to access most of the internet content that is available in Western countries. So today we are going to discuss how VPN technology works itself and how existing governments like China's Great Firewall trying to block it, and how essentially to avoid that block. So VPN stands for Virtual Private Network, which essentially tries to organize your entire network access to the rest of the internet. It's essentially a forwarding protocol that forwards your entire internet traffic to the VPN server provider that simulates whether you visiting any website in a way that it pretends that you're visiting that website through that server. So essentially it forwards entire your internet traffic or outbound network to that server, then that server forwards to the website that you are trying to visit. So the purpose of this technology creation was back in 1990s, where Microsoft employees wanted to access their internal resources when they were away from their office, or when they wanted to connect multiple services together that have been in multiple different locations. So VPN initially created for businesses, and the use case was just to access internal resources when you are away or you are not physically on that location. It is the way of forwarding entire internet traffic from your local machine to that specific network address range that business have. The main benefit that businesses were getting back then was that, and even today, that employees are able to access and work with the internal resources and by faking their IP address on the internet, so that internet service provider doesn't have to change anything on their end to be able to allow you to access to some private resources that are available outside of their network scope. But as a side effect, it actually gave a huge benefit of keeping your IP address private and accessing internet resources that are not available on your region, because you are essentially faking that you are accessing through another network interface. The main benefit there comes from accessing different geolocation. Let's say if I am in US, I can access to some resource through UK server that is not available to me, and that internet website which is getting the traffic from my computer, it doesn't see my IP address, it actually sees the VPN server provider, which probably located somewhere in Europe. To understand how technology works itself, first let's take a look at a very simple example on how to build very simple tunneling interface using Go programming language, which is very simple. It actually a few lines of code, because most of the functionality is already embedded throughout the operating system that you are using, whether it's Windows, Mac, or Linux. They all have the same concept of tunneling, and essentially VPN server creates that tunnel, and whatever you write to that tunnel from your network driver or your local machine, it just forwards that data to the server, bypassing all that limitations and sending that over to the target internet resource and getting back a response the same way by forwarding that internet traffic back to your local machine. So essentially you are simulating the process of IP headers that have been being sent throughout that server instead of your local machine directly. But this simple implementation essentially doesn't have any encryption. It just forwards the entire traffic. But the big part of VPN is to actually secure the data transfer between your local machine and the VPN server itself, so that somewhere someone in the middle, like ISP provider, can't actually see what you're actually transferring, because that will be easier to block if everything was available to read and write by the ISP provider. So the methodology of VPN providers that they are using, they are essentially encrypting everything that gets sent from your local machine to a remote server, and where it gets decrypted to send forward to the target internet resource. Let's say if you are visiting some website outside of your internet scope, the VPN provider encrypts everything on your local machine and decrypts everything on the target server resource to send the forwarding request to the target internet resource and get it back. And so from the perspective of ISPs, you're actually sending some junk information and they can't see anything because all of the data gets encrypted on your local machine, and throughout the dedicated server that VPN provider has, nobody can decrypt that data anymore. So that encryption is actually making whole this privacy concept available, but the VPN itself, it just enables geolocation based internet resource access, and that's the functionality behind it. The encryption part makes it available for the privacy perspective and encrypt your entire internet traffic without giving an access to internet service providers, which websites are you using or what type of content you are sending throughout your local machine. And that's why the internet server providers, especially in China with their Grate Firewall, they are trying to block that, because they have a huge problem of controlling the internet, similar to other countries as well. But the concept there is that they're trying to block essentially the outgoing the packets, because they already know what type of content they are looking for. They have the system in ISPs that essentially monitor whether they match a content. Let's say if they identify the internet traffic to some external resources that should have been done, they just block the connection. But with VPN, because there is an encryption in the middle, internet server providers can't essentially read through packets and understand what type of traffic is going on. However, they got pretty smart over the years, and the VPN technology evolving as well. So China now, with the Grate Firewall, they actually started to identify different types of VPN providers and can actually scan the content. But VPN server providers got a bit smarter, so they started to implement things like rotating IP addresses, where they reassign new IP addresses whenever they got blocked. But the war goes on in that sense of internet censorship tries to block VPN connections, because that's potentially harmful for their monitoring purposes. And the VPN server providers essentially try to bypass that in any cost. There is more things than standard VPN connections to bypass these type of censorships, especially when you don't have any other options, and VPNs can be literally blocked entirely, because most of the providers have a static IP addresses, and changing those all the time is quite costly. And if you don't have that much money, there are some regions that entirely blocked, but still technically there is a way of doing that. It calls the shadow socks, which is a secure proxy way. It's not entirely a VPN, but you essentially can proxy a single port and forward the entire traffic through that port. Let's say if the use case is to allow people to access to websites, that's possible to do, just forwarding entire HTTP or HTTPS traffic by specific ports that can be controlled because of the HTTPS protocol security limitations, that they can't monitor that entirely. It is quite easy to set up your own VPN server as well, but the existing VPN server provider prices are quite cheap nowadays, and it doesn't make sense kind of to spend all the time setting everything up. But there is still huge use cases also on the business side, where, for example, if you are deploying some private infrastructure, you have to have access to that even if you are outside of your organization network. That's where the organizational VPN comes very handy. And OpenVPN server is probably the most used one, but there is also way optimized protocols nowadays like WireGuard, which is essentially using about 2 to 4 times less internet traffic than OpenVPN because it's very lightweight. Also on server side, you can literally set it up within a couple of seconds, and your dedicated server won't be as involved in the network traffic as with OpenVPN server. Let me know in the comments if you want to see another video on how to set up OpenVPN server or WireGuard server that essentially will allow you to connect throughout your local machine to your dedicated VPN server. I will be happy to set it up.